Alright, I know I don't always do a bell ringer, but please, I want you to write down as many trig identities as you can remember from yesterday, so pause that video and try it out. Cool. If you have the extra variations, great. If you have the reciprocals, even better. Alright, talking about complex numbers. So remember, if you see I is the same thing as the square root of -1. If you see I squared, it's just -1. Why does that work, you ask? Well, if I square both sides, I'm left with I squared. Squared and square root cancel each other out. That's how I get that guy. Okay. Let's do some practice. Yeah. Square root of 25. I understand there's a negative there, but let's focus on the square root of 25. What is the square root of 25? Good, it's 5. Now what's the square root of that -1 part? I. So the square root of -25 is 5i. What about square root of -7? Well, the square root of 7 is not a perfect square, so he's going to stay under there. But I can bring out that negative by bringing the I out front. No, I'm sorry. The square root of -9 minus 2 times the square root of -25. We cannot do anything with those unless they're the same underneath if we're adding and subtracting. Since we are subtracting and they're not the same, we have to try and reduce all of the radicals down. So, square root of 9 is just 3. We bring that I with. -2 times, we already said that the square root of -25 was 5i. So I have 3i minus 10i. And I can treat my complex numbers, my i's, just like I did any variable, whether it be x, y, z, or your favorite letter. So 3 minus 10 gives me -7. And again, it's not squared, it's not cubed, it's not anything else. It's just by itself. Take a pause. Do this fourth one. Should get a -32i. Alright, let's go ahead and add, subtract. So you can only add or subtract with whatever is connected to each other. So for example, a regular number like 2 can only be added or subtracted with the regular numbers, like 4, 7, 10. If you've got a 3i, you can only add or subtract those with the other i's. You don't get to just magically put them together. So you can only put the like stuff together. It's like when you added 3 and 7x. You couldn't put those together, but you could have 3 with 5 and 7x with 10x. Same idea. So this first one. I have 2 plus 4. 6. I have 3 plus 5. 8. So my answer is 6 plus 8i. 7 minus 9. -2. 8 minus 5. 3. Again, that I comes with. 6 plus 6. 12. 9 plus 7. 16. 4 minus 5. It's a -1. 3 minus -2. What happens when you have two negatives next to each other? It flips it, it becomes positive, so you actually have 3 plus 2, which is 5. Alright, complex conjugates. Conjugates means that what we're going to do is we're going to multiply Just scoot that over a little bit, because I know you have more room to the right than I do. You're going to multiply by the bottom. You're going to multiply everything by the bottom with the opposite sign in the middle. Again, I was running out of room. So we're going to multiply this first one by 4 minus 3i over 4 minus 3i. The idea is to get rid of the i's, or the imaginary, the complex stuff in the denominator. We don't like having non-real things in the denominator. Remember, complex is imaginary. So we're going to multiply this like we would multiply anything. We have to FOIL because we have 2 terms each, so we have to FOIL. 5 times 4 gives me 20. 5 times negative 3i is a negative 15i. Negative 2i times 4 is negative 8i. Negative 2i times negative 3i is a positive 6i squared. That was the top. Now we have to do the bottom. 4 times 4 is 16. Then 4 times negative 3i is negative 12i. Then 3i times 4 is a positive 12i. Then 3i times negative 3i is negative 9i squared. Next, we're going to simplify. This is where putting the same stuff together comes into play. So I have 20. He's the first real number up top. I have negative 15 minus 8 give me negative 23 plus 6. What did I say I squared was equal to? I squared, only I squared, is allowed to be broken into a negative 1. On the denominator, I have 16 minus 9 times negative 1. Remember, those 12s cancel each other out. They're gone. And again, I have another I squared, so I replace the I squared with a negative 1. 6 times negative 1 is a negative 6. So I have 20 minus 6, which is 14, minus 23i. I just realized I didn't put that I apologize. Negative 9 times negative 1 is 9. So I have 16 plus 9, which is 25. So my answer is 14 minus 23i divided by 25. Alright, we're going to do the same thing over here. We're going to multiply by 3 minus 2i over 3 minus 2i. So I have 3 times 3, which is 9. 3 times negative 2i, which is a negative 6i. Negative 2i times 3 is a negative 6i. And negative 2i times negative 2i is a positive 4i squared. Then I have 3 times 3, which is 9. I have 3 times negative 2, which is negative 6i. 2i times 3, which is positive 6i. 2i times negative 2i is a negative 4i squared. We're going to put the like stuff together. So I have 9 minus 12i plus 4. We're going to replace that I squared with a negative 1 over 9 minus 4 times that negative 1. Again, replacing that I squared. Four times negative 1 is a negative 4, so 9 minus 4 is 5. Minus 12i. Negative 4 times negative 1 is 4, so 9 plus 4 is 13. So my final answer is 5 minus 12i over 13. Alright, your homework is another worksheet.